Well, good morning, everybody. Thank you for coming. We have this room just about full, and luckily I see lots of friendly and familiar faces, so that's good. That'll probably make this go a little bit easier. So, 11 years ago, Mark Spencer released this little project called Asterisk, which in that time has turned into the largest force for change in the world of telecommunications. It has provided open source tools for people to build voice-based applications to solve problems in their businesses. And it has made its way into countless applications around the world, citywide municipal deployments, even installations that will call you to water your plants when they need water. In fact, it has delivered telephony to the masses without restriction. On top of all of that, the world has moved to voice over IP, and Asterisk has been the backbone of that occurring. No other platform has as much reach or as broad a usage as Asterisk does. In fact, Asterisk will be downloaded 2 million times or more this year. And just last week, the Asterisk development team released Asterisk 1.8 with lots of new and exciting features. And they're already hard at work on Asterisk 1.10. You can actually hear more about that during a talk tomorrow afternoon by Russell Bryant and Leif Madsen and probably some other members of the Asterisk development team. But right now, we're going to take a short look at exactly how big the Asterisk world has gotten. So this room holds about 800 people, although we don't actually have 800 of you here, but just imagine 800 people in here. In the past 7 years, there's been 9,800 people who have actively helped in the development of Asterisk. That's enough to fill this room 12 times. It's even enough to fill this massive hotel that everybody gets lost in 5 times over. Now up on the screen, you can see a picture of a city called Scranton, Pennsylvania. Those of you from the US probably are familiar with this as the home of the NBC sitcom The Office. What you're probably not aware of is that there is an online community that is actually the same size as Scranton. It's the asterisk.org community. Right now, there are 73,000 members of the asterisk.org community. Same size as a small city, believe it or not. Turns out that's actually even enough people to fill Lambeau Field, home of the Green Bay Packers. Now, we're talking about big deals, so let's talk about another one. If you had 1 million servers, what could you do with that? Well, you could certainly build a Google, although we have one of those already and everybody's pretty happy with it. You could build 2 Microsofts. You could even build 10 Facebooks. But what we see is there's at least 1 million servers around the world running Asterisk right now. We can even have a map that shows you where all of these Asterisk servers are, kind of like the maps you see in cell phone carrier commercials. There are Asterisk servers that we can verify in 162 countries around the world. There's a few on that map that aren't orange, although it's kind of hard to tell on the screen. We're pretty sure that there's actually Asterisk servers in those countries too. We just can't verify that. So, if every user who has a phone attached to an Asterisk server made just 1 call every day, there would be over 3,000 calls made just in the time it took to say that sentence right there. Now, in that 11-year time, Asterisk has become something that has changed the way everyone communicates. It's used all around the world in countless ways. However, we have heard from a lot of people that there are ways that they would like Asterisk to be better. So today, we're going to have 3 of our longtime community members tell you some stories about the way they use Asterisk and their wishes for Asterisk and how it could be better. The first of those is Tim Panton from PhoneFromHere.com, who's going to tell you about how he helped to deploy mobile communications on a very small island in the Pacific called Niue. Tim?
So I'm Tim Panton from PhoneFromHere.com. Normally we bring voice to places where it isn't like websites, but in this particular case we brought voice to a small island in the form of GSM connectivity. Now, when I first started this project, I didn't know where Niue was, and I'm sure that almost none of you do either. So the I will do what I did first time, which was to Google map it and see where it was. Well, it's an island. Okay, that's good, but where is it? So I zoomed out a little to try and see, and that didn't tell me a great deal. And it still didn't tell me a huge amount. So I zoomed out some more, and finally I start to get a few clues, but I'm really not that good at geography, so I don't know where we are yet. And okay, well, we're in the middle of an ocean. No. Yeah, okay, now I know where we are. We're halfway between New Zealand and Hawaii. So basically a long way from anywhere, kind of like Huntsville in that respect. So getting to Niue is kind of interesting because there is one flight a week from Auckland. There's one boat a month, but that's not a ferry, that's a cargo boat. And otherwise, the only way to get there is hitch a lift on a passing yacht. So you have to plan ahead, and you have to take what you want to, what you're going to need with you. So, and the flight is just astonishing. You get on a flight at about 9 o'clock in the morning on a Saturday, the one flight a week, and you arrive at lunchtime the previous Friday. So when I first heard about this project, it was indirectly through the Asterisk mailing list. There was a question on the Asterisk mailing list from David here, David Burgess, about he needed some help with the OpenBTS project, and I happened to know the answer, so I emailed him, and I learned about OpenBTS. And at some point later, I got an email which said, from somebody who claimed to be responsible for the economic development of a small island, who wanted my help with the project. And it turns out it actually wasn't spam. So I Googled the guy, and he is, and so the project. And so I dug into the project, and what they were aiming to do is to bring a low-cost GSM telephony, so mobile phone coverage, to an island that had no mobile phone coverage. And so I got the T-shirt and went out there, and that's what we did. Met some interesting guys, and we put this pilot project together. So Niue is surprising in so many ways, but I don't know, maybe some of you are old enough to remember what it was like organizing a day for a distributed team when you didn't have a mobile phone. Okay, when mobile phones weren't there, what you had to do is start your business day with a meeting. There was a team meeting in which you planned how the day was going to go and who was going to go where and what they were going to do. And then through the day, the team members had to go and do those things, even if it turned out they weren't necessary, because otherwise they wouldn't be in the right place and you wouldn't be able to find them. So that still happens in Niue because they don't have mobile phones. So they have a kind of hack for it, though, right? And what they do is they wave a lot. So they wave. Whoa, what happened there? Right. So they wave a lot. And what this means is that you can go to somebody and say, "Did you see where the radio guys went?" And they say, "Yeah, sure. They were going that way." And you drive along a bit and ask again, and you can find them. Now, this works on an island of 1,500 people, but it's kind of not really modern real-time communications. So they wanted a GSM network, and we used the OpenBTS, which is an open source product, in combination with Asterisk to provide an open source network, open source GSM network, which they could use with their existing GSM mobile phones, which they've all got because they all holiday in New Zealand or Hawaii, but typically New Zealand because that's where the flight goes. And so they all have these things, so you can just provide them with telephony that way. Now, one of the great things about using Asterisk in this context is that it's configurable. We were able to build the thing in the way that they wanted. And an example of that is provisioning. Now, provisioning on Niue consists of taking your phone and walking or driving to the telecom office, taking it in and saying, "I'd like this provisioned," because that's culturally the way they want it done. And with Asterisk, we can set that up. Now, the other thing about Niue is because it's so far from anywhere, they are incredibly self-reliant. And we were asked, or David, in fact, was asked in a radio interview, how this new telephony system would be different from all of the other things that have been put on the island, the proprietary systems that have been put on the island, that they can't maintain. And David's answer was a really good answer in terms of the open source philosophy, which is that you have all the documentation, you have all of the source code. You have all of the diagrams of the hardware here, and you could build another one from that data. And we provided them with all of that information, in fact, with one exception, which was the antenna mount, because we brought the wrong one, and these guys had to build us one instead. So, and this mechanical PBX is really in the telecom office, and it's there for a very good reason. It is the absolute last resort phone system. If they have a catastrophe there, and they have them. They had a cyclone in 2004 that pretty much wiped the island out. If they have a catastrophe there, they can fall back to that. So fault tolerance is a big issue for them. And we only built a pilot network, so we had a couple of asterisks, and they talked to each other and this kind of stuff. But that's not real. You know, if one of them went out, the system would probably not deliver. So what we would have liked and what we would want to do is to build something that was more fault tolerant than that. And so my wish for the future of Asterisk and for the future is to have something where it is easier to build a loosely coupled, fault-tolerant network of Asterisk systems.
All righty. Thank you, Tim. So unlike most of us, Tim gets to take a vacation to this tiny island out in the Pacific. Turns out they needed Asterisk too. So next, we're going to hear from Alistair Cunningham of Integrix. He's going to tell us about NSwitch and how they use Asterisk to build solutions for their customers. Alistair?
Thank you, Kevin. Good morning, everyone. I'm Alistair Cunningham, founder of Integrix. As some of you may know, we're the creators of NSwitch. In early 2005, with voice over IP rapidly gaining in popularity, we saw a market need for a scalable, affordable, carrier-grade soft switch for commercial telephony services. Other products on the market at the time were either feature-limited or priced unaffordably, so we began our NSwitch project. Immediately, we were faced with the question of which platform to use for telephony. Well, as luck would have it, we were aware of a small open-source project called Asterisk. Fortunately, over time, that project has become rather successful and a large open source project, which is why we're all here. NSwitch was originally planned for hosted PBX services, but we quickly expanded to include residential services, SIP trunking, number translation, and similar services. We decided to include billing and invoicing and resellers from day one, and today, with a lot of effort, we've built the best solution on the market. We chose Asterisk because it's an excellent platform for building high-level telephony services. It provides abstraction for a number of protocols, such as SIP and IAX. It supports a wide array of hardware. It provides real-time database-driven configuration. And most importantly, from our point of view, it provides the fast AGI and manager interfaces, which we use to connect to a full routing and billing engine. With NSwitch, customers can build very large, very scalable systems with hundreds of thousands of users and many thousands of concurrent calls. Since one Asterisk machine can't handle, for example, 200,000 users or 50,000 concurrent calls, we use multiple Asterisk machines in parallel to achieve scalability. This, however, raises a few challenges. Firstly, at the time we created NSwitch, Asterisk didn't know about state on other machines. It didn't know what calls were active elsewhere in the cluster, and it didn't know which handsets were registered to which machine. This meant that features like busy lamps, queue status, conferencing, were limited to a single Asterisk machine. To overcome this, we implemented an external SIP proxy and registrar and added lots of our own code to distribute state information throughout the cluster. A second challenge is when deploying machines, we needed to know which machines were up and capable of processing calls, and which machines were down, perhaps because of maintenance or perhaps because of a fault. To do this, we added a service